Good morning, everyone. It's Miss Minneely, and I'm going to go through a couple of examples of solving systems of equations that involve three variables with three equations. I'm going to start off with a basic example, and then in the next video, I'm going to show you something that's a little bit more challenging. So when you start off with a system in three variables, remember you need to have as many equations as you have variables in order to determine a solution, if a solution exists. It's still possible that there is no solution or that there are infinitely many solutions, and the way you determine that is as you're solving, if the variables cancel out and you're left with a statement that's true, you know that generally means that there are infinite solutions. If you're left with a statement such as 0 equals 7, that would be an indication that there is no solution to the system. We're going to look at two examples, though, that do have solutions, and I'm going to work through the process. Each of you was given a template with the steps needed to solve a system with three variables. So I'm going to go through the template with this particular example. So in number one, or in step one, it says to pick two equations and eliminate one of the variables. One of the first decisions you need to make is which variable you want to eliminate. So you want to look for the coefficients. You want to look at the coefficients of the variables. And one of the things that I notice is that my y variable, all of the coefficients are either positive 2 or negative 2. What's nice about that is that when I combine a positive 2y with a negative 2y, I know that my equations, my y variables, are going to cancel. If I wanted to choose the x variable, I could do that, and same with the z, except I'm going to need to multiply one or both of the equations by a scalar in order to get something to cancel. For example, if I was looking at these two equations and wanted to cancel the x, the 3x and the 2x won't cancel out. So I'd need to find a number that both 2 and 3 go into evenly and then make one of them opposite. So for example, I could multiply the top equation by a negative 2, and that would leave me with a negative 6x. If I multiply the bottom equation by a 3, that would leave me with a positive 6x, and those x's would cancel. But to save time and to save a step, you really want to look for a variable that already has coefficients that are either multiples of each other or are already opposite. And with the y variable, that's already the case. So it says to pick two equations and eliminate one of the variables. Well, I'm going to go ahead and choose these two equations because if I combine them the way they are, the negative 2y and the positive 2y are going to cancel each other out. So I'm going to go ahead and write them down. So I've got 3x minus 2y plus 2z is equal to 14. And then my second equation, we have 2x plus 2y minus 3z is equal to negative 7. And so the next step is now to do my combination or my elimination. If I add the two equations together, then my y's cancel. And I'm going to be left with a 5x. And then if I look at my z's, a positive 2z together with a negative 3z is going to leave me with a negative z. And 14 minus 7 obviously is going to be 7. That equation I'm actually going to put in this box right here. And notice that I'm now left with one equation in two variables. I no longer have that y variable. So in order to solve for x or z, I need another equation that has an x and a z in it. So in step 2, it says now pick two different equations and eliminate the same variable. So again, I want to eliminate y, but I need to choose two different equations. And I notice that the second and third equations, in one I have a positive 2y and in the other I have a negative 2y, so I don't have to change anything. If I add those two equations together, the y variables are going to cancel. So again, I'm going to write the two equations out. So we've got 2x plus 2y minus 3z is equal to negative 7. And then in the second equation, or the third equation, I'm sorry, x minus 2y plus z is equal to 7. And now if I combine those two equations, again, my y's cancel, which is what I want to happen. And when I add the two equations together, I'm going to get a 3x. I've got a negative 2z plus z. It's going to leave me with a negative 2z. And then notice that I end up with negative 7 plus 7. That's going to give me 0. One of the things I noticed on the quiz that we had the other day is sometimes when you get to a place where there is a 0 on one side, suddenly students think that there's no solution. But it's okay to have variables on one side of an equation and 0 on the other. It's still solvable. It's only when the variables cancel out and you have 0 on both sides that would be an indication that there are either infinitely or no solutions. So again, I'm going to bring this equation down. So I've got 3x minus 2z is equal to 0. So now I have two equations in two variables, the same two variables, which means if I put them together, I can actually solve for x and z. So at this point, I'm back to where we were in our original couple of classes. So now it says to write a system of equations using the final equations from box 1, that's this box, and box 2, that's this box. So I'm going to put them together. 5x minus z is equal to 7. And then in the other equation, we have 3x minus 2z is equal to 0. And so now I'm back to where we were last week. I need to figure out which variable I want to eliminate. And again, I want to look for variables that are going to be easy to eliminate. If I look at my x's, I've got a positive 5x and a 3x. Those aren't going to cancel as is, so I'd need to multiply one or both of the equations to get them to cancel. Since 3 doesn't go into 5 evenly, I'd have to actually transform both equations. It's actually going to be easier to eliminate the z variable, because I've got a negative z and a negative 2z. It would be so awesome if in that first equation I had a positive 2z. Because if I had a positive 2z, it would cancel with a negative 2z. So I want to think about ways, and remember there's just a 1 in front. How can I transform that negative 1z into a positive 2z using multiplication? And the answer would be to multiply by a negative 2. Because if I multiply negative 2 times negative 1, I'm going to get a positive 2. Now, when I rewrite my equation, I do need to make sure that I distribute that negative 2 to each term. So negative 2 times 5x is going to give me a negative 10x. When I multiply the negative 2 times the negative 1z, I'm going to get a positive 2z. And then don't forget, you also have to multiply through to the other side. So negative 2 times 7 is going to give me a negative 14. My other equation, I don't need to change, so I'm just going to rewrite it as 3x minus 2z, and that's going to equal 0. And when I add the two equations together, my z's will cancel, and I'm going to be left with a negative 7x is equal to a negative 14. And this is solvable. If I divide both sides by 7, or I'm sorry, by a negative 7, I get that x is now equal to 2. So I've already got one of my variables solved. The next thing, I want to move to step 4, and it's going to be to substitute the value from box 3, that's this box here, into one of the equations from box 1 or 2, which are basically the two equations that we have here, and solve for the unknown variable. So we're just going to solve for z like we did before. So it doesn't matter which equation we use. I'm going to go ahead and use the equation from box 1, where we had 5x, except instead of writing an x this time, I'm going to put parentheses to hold its spot. Z is still unknown, and I'm just going to write the equation the way it was, but instead of writing an x, I'm going to replace it with a 2. And now I'll solve. So 5 times 2 is 10, so basically we have 10 minus z is equal to 7. If I subtract 10 from both sides, I get that a negative z is equal to a negative 3. And if a negative z is equal to a negative 3, that means a positive z would equal a positive 3. Or you can think of a coefficient of, if z has a coefficient of negative 1, if I divide both sides by negative 1, now I have the value for z. So now I have the values for x and z. In step 5, I'm going to take those. It says to substitute the values from box 3, that's this box, and box 4, that's this box, into one of the original equations. So I want to go back to one of the 3 original equations that had the 3 variables, and I want to solve for the remaining variable, which in this case would be y. So I'm going to go back and I'm just going to choose that bottom equation. So I've got x minus 2y plus z equals 7. But again, instead of writing x, I'm going to put parentheses. It's the 2y, or the y in this case, that I am trying to solve for. So I'm going to leave it as minus 2y plus z. Again, I have a value for z, so I'm going to leave parentheses there. So all I did is kind of write the skeleton of the equation. And now I'm going to fill in what I know. I know that my x is 2 and that my z is 3. And so now I just need to solve that equation for y. So I can go ahead and combine the 2 and the 3. And this means that negative 2y plus 5 is now equal to 7. If I subtract 2 from both sides, let me move this up a little bit, I'm going to have that negative 2y is equal, oops, I need to subtract 5, sorry. If I subtract 5 from both sides, then I have that negative 2y is equal to positive 2. And if I divide by negative 2, I get that y is equal to negative 1. So now I have my solution. If I put it in an ordered triple, it should look like x is 2, y is negative 1, and z is 3. And then it says to check your answer in all of the original equations. And in this case, I would basically substitute the 2, the -1, and the 3 into each of the original equations to make sure that it works. I'm going to go through this process because there is a problem like this on your quarterly assessment that requires you to do so. So the original equations, I have to, actually, let me just do it up here so I don't have to move back and forth. So our solution was 2, -1, 3. Okay. And so then what you'd want to do in that last box is simply plug your solution in. So actually I can fit it down here. So we've got 3x minus 2y plus z equals, or plus 2z equals 14. So I'm just going to plug it in. 3 times x minus 2 times y plus 2 times z is equal to 14. And if I plug in the 2 and the -1 and the 3, I'm just going to use my calculator to check to make sure that's true. So this is going to give me a 6. -2 times -1 is going to give me a positive 3. So if I add 6 to 3, I get 9. And then if I multiply, did I do that right? I'm sorry. -2 times -1 is 2. So if I have 6 plus 2, that's going to give me 8. That's plus another 6, and that's going to give me 14. Sorry. And then in the second equation, I've got 2 times x plus 2 times y minus 3 times z, and that's supposed to equal -7. And if I plug in my values, 2, -1, and 3, I can double check. 2 times 2 is 4. This is going to give me a -2, and that's going to give me a -6. So 4 minus 2 is 2. If I add 3 times 3 is actually 9. That's going to give me a -7. Sorry, I'm not with it right now. And finally, that last equation, we've got x minus 2y plus z, and that's supposed to equal 7. Let's see if I can do this without making a mistake this time. So we've got a 2, a -1, and a 3. So -2 times -1 is going to give me a positive 2. So 2 plus 2 is 4, plus 3 is 7. And so you can check your answer to make sure that the solution works for all 3 of those equations.